Okay, so we're looking at direct variation. We're looking at direct variation. In this particular case, we've got, and now these are done with practical problems as well, but we always start off with these very, very abstract things. We know that y varies directly with the cube of x. So I'm going to highlight that. Y varies directly with the cube of x. And then it is known that y equals 24 when x equals 2. So what we have to do is write an equation. Okay? So what's it going to look like? Think about what it says in the previous thing, and I've highlighted it in yellow. What's it going to look like? Y varies directly with the cube of x. What's our equation going to look like in the end? It's up there and it's highlighted. Y equals is a good start. What was the next bit? A, x. Y varies directly with the cube of x. All right, 2. Do we refer to that as cubed? 3. The other one would be the square of x. You're on the right track, but it would be the cube, which is the 3. Cool? Now, that's your end game. That's what it's going to look like. So we're probably going to end up with an equation that looks like that. First step it asks us to do is write a proportion statement. Now, if you were listening to me about 4 minutes ago, you'll probably know what a proportion statement is. If you weren't, then you're going to be sitting there with a blank look on your face. We need to write a proportion statement. Now, funnily enough, it's going to have a symbol in it that I've just introduced to you that I mentioned says in proportion to. Fishy. Okay, so now I want you to write a proportion statement. Now, you know it's going to have a fish in it because that's the is in proportion to. Yes. Y is in proportion to. It's not to x, it's to the cube of x. So that literally says y varies directly with the cube of x, or y is in proportion to the cube of x. Everyone happy with that? Okay. Now we know we want to get back to this y equals ax cubed. What the hell is a? Yep, but we're not thinking about it as part of the alphabet. We think of it, if you have a look at the area of the circle, a equals pi r squared. What did we say that pi was? It's highlighted up there, and no, it's not a piece of food, but thank you for being contributing. It is the constant of? It's the constant of variation. Sorry? Pi was the constant of variation in that particular case. So what we need to do is we need to find the constant of variation. Do we know what the constant of variation is at the moment? No, otherwise we could write the equation down. So what we're going to do is we're going to give it a letter so that we can work out what it is. What letter would you like to use for constant of variation? I'll give you a hint. It's in between J and L. Excellent. It's a good choice. So, we have now written an equation, and you'll notice it looks like y equals ax cubed. Jacinda, good question. Why does it have to be k? Why not c? We use c in too many other things. Why can't it be z? It could be. But k is closer to constant than any other letter that we've got. Do you agree, Levi? William's not going to be happy that you said that about him, but okay. Y equals kx cubed, where the k is the constant of variation. Now we need to get an equation. What do we need to find out? What is the one thing that's missing? We know we need a y variable because that's our dependent variable. We know we need an x variable because x is our independent variable. What's the one thing that we need to not be a variable anymore? We need it to be a constant of variation. The k. So basically what we're trying to do is find out what k equals. Okay, you know how you want to know what am I trying to do to answer this question? What do I have to find out? You have to find out what K equals. Once you've found out what K equals, you can write down this equation. All right, so Levi. All right, so we want to find out what K equals. Is there any way that you think that we might be able to find out what K equals? Sorry, mate? What did you say? Sorry, I missed it. Substitute what? Excellent. We've got three unknowns there, y, k, and x. But in the question, they've given us a y and an x. Y is 24 when x is 2. So we can sub them in and hopefully solve it and find out what the hell x is, yeah? Okay, so y is 24. So let's go, we'll start subbing that in. So 24 equals k 2 cubed. Cool? Put the bracket in the wrong spot, sorry. Doesn't really matter, but I like to be consistent. So I've just put the bracket around what I've substituted in. So we now know that 24 equals k times 2 cubed. Anyone know what 2 cubed is? 2 cubed is, thank you. So we know that 24 equals 8 times k. What does k equal? Sorry? Did you say 3? Are you sure? I thought I heard you say 3. 3, yeah. To find out what it is, you've got to divide both sides by 8. So just remember that's 8 times k. How do we get rid of the 8? We divide. Okay? So, oops. I'm sure you said 3. So 3 equals k. Awesome. Have we finished? We've got one more thing to do. When you say do the exact same thing, what do you mean? Excellent. So write down the equation with the k in it. So what are we going to do? So we know that y is the dependent variable. Do we know what k is now? 3. And then we've got our independent variable there. And you have now written down the equation. And you are finished. Sorry? Thank you. Yeah, I do start from the bottom a lot. I don't know. It's because no one ever taught me to write properly. Hence, I became a maths teacher. I learned to count proper like so that I could hide my stupidity. It works sometimes. Then I talk. Stupidity comes out then.